Hi everyone. Now we are going to discuss about electrostatics of conductors. Conductors are the substance which can conduct electricity or heat through it. So here we are going to discuss about electric conductors, the substance which can conduct electricity. Substance which can conduct electricity is known as conductor. Conductors like metals conduct electricity because metals have free electrons in it. These free electrons can move. So the reason for conductivity of a metal is the free electrons present in it. The free electrons can move everywhere in the conductor. They cannot move outside of the conductor. It cannot move outside of the metal, but it can move everywhere in the conductor. Electrostatic field inside conductor is zero. If there is no electric field, so there won't be any electric field inside the conductor because there is no electric field. But if there is an electric field, still the electric field inside the conductor is zero. We are going to discuss the reason behind it. So we are considering a conductor, and it is a conductor. It is having free electrons. It can conduct electricity, and we are applying an external electric field. So this is an external electric field. It is starting from positive. Electric field lines are starting from positive and ending into negative. So direction of external electric field is from left to right. This is the direction of the external electric field EO. E outside, external electric field. And because of this external electric field, there are number of electrons inside the conductor. It will move towards the positive charge. Here this is the positive charge, so the negatively charged electron will move towards the positive charge. It will move towards the positive charge, and this side is going to become negative and this side is going to become positive. So there will be another electric field inside the conductor, which will be from starting from positive to negative. So this is the direction of internal electric field EI. This internal electric field is opposite to the external electric field EO. So when the EO is equal to EI, when EO is equal to EI, it will cancel each other. Then the electric field inside the conductor will be zero if there is external electric field also. At the surface of charged conductor, electrostatic field must be normal to the surface at every point. So we are considering a charged surface. The charge of this surface is plus Q, and there will be electric field line which is perpendicular to the surface. This is also perpendicular. These electric field lines are perpendicular to the surface. Now we are assuming there is an electric field line which is not perpendicular to the surface. It is not perpendicular. So there will be two components. There will be rectangular components of this vector. Electric field is a vector. So these are the rectangular components of this vector, and this component of vector will make the charge to move. There are number of charges on the surface of the conductor, and because of this rectangular component there will be a force, and because of this force the free charge on the surface of the conductor experience a force and it will move. It is not possible. So at the surface of charged conductor, electrostatic field must be normal to the surface at every point. The interior of conductor can have no excess charge in the static situation. If we are giving excess charge in a conductor, it will spread throughout the surface of the conductor. A neutral conductor has equal amount of positive and negative charges inside. So this is the a conductor which is having a charge, and the charges will be always at the surface of the conductor. Electric field inside the conductor is zero. According to Gauss's theorem, we have the equation phi is equal to q upon epsilon 0. So since there is no electric field inside the conductor, there won't be any flux. So if the flux is 0 inside the conductor, then the charge will be 0, because from this equation we can see that if the flux is 0, the charge will be 0. There is no field inside the conductor, so there is no flux inside the conductor. It means there is no charge inside the conductor. All the charge will be distributed on the surface of the conductor.